Okay, so I'm going to combine chapter 1 and chapter 2 together because chapter 2 we're only going to learn about 2a and 2b, which is the simple part of the equations. There's no harmonic stuff or whatever it is called. So the first thing is about trigonometric identities, and there are a lot of identities that you have to know. So I put all of them in one paper. So yeah, I'm not gonna mention the identities every single time. These are the but you need to memorize all the identities that are in the paper. So there's one thing that you might be confused of. This plus minus sign. Let me just connect my pen first. You will see in the compound angle identities, you could see a plus minus sign and then a minus plus sign. What that means is if one is plus, then the other is minus. So if it's cos A plus B, then it will be cos A cos B minus sin A sin B, and vice versa. So okay, now I can use the pen. So I'm gonna go through the first questions first. They're gonna get harder by time. So this one prove each of the following trigonometric identities. So LHS equal to sine square theta over 1 minus cos theta. So the thing you want to try and do is you want to try and connect this to this. So how would you connect them? The best way to connect them is by letting sine square theta equals to 1 minus cos square theta. As you can see in the identity here. So you can move around the number, you can move around the cos square theta. So sine square theta equals to 1 minus cos square theta. And then after that, it is a plus a square minus b square. So it will be a plus b, a minus b. Cut out that, and then you get 1 plus cos theta, which is equal to the right hand side. And then for the second, for C, the right hand side is equal to sec square theta plus sec square theta cosec theta minus sec theta tan theta. So convert them into cos and sine. Then you will get 1 over cos square minus cos square theta sin square theta minus sin theta over cos square theta. So this sin theta over cos square theta is equal to sin square theta over cos square theta sin theta, because this is already cos square theta sin theta. So 1 minus sin theta over cos square theta sin theta, then that's equal to cos square theta. Then you can cut out the cos square theta, and then you will get 1 over sin theta, which is cosec theta. So you want to try and find the connections. There are many ways you can find the connection. One is trying to remove the one. Another one is trying to turn this square into normal. And then there's others that include like changing double angles into single angles, or changing single angles into double angles. So you'll get what I mean later. Okay, this one is about the compound angle. So if you see a question like this, you're like, how do I want to find what angle this is without using calculator? So what you want to do is you want to separate it into 2 types of angles, which you can find using without calculator. So in this case, it's 45 and 30. If you use 45 and 30, then you will get sin 45 cos 30 plus cos 45 sin 30, because that's the formula for this. It is sin x cos y plus cos x sin y. So since you know 45 and 30 got your own special identities, you sub them in and then you find the answer. And then if it's 15, this one you cannot plus, so what you do, you minus instead. So if you minus instead, you will get cos 45 minus 30. So it'll be cos 45 cos 30 plus sin 45 sin 30. Again, sub in the values and then you will get the answer. The next one, prove the following identities. I'm going to talk about B because B seems very confusing. So sin A plus B is this, sin A minus B is this. So sin A cos B plus cos A sin B minus sin A cos B minus cos A sin B. At first thought, I was like, how did this turn into this? Then I realized, plus, minus, cut, plus, minus become plus. So cos A sin B plus cos A sin B is 2 cos A sin B. Since the denominator is cos A sin B, I can just cut it out. I can cut out the cos A out. So if I cut out the cos A, be careful if it's sine of cos. That is very important. So if I cut out this part, then I will get sin B over cos B, which is equal to tan B. So it will be 2 tan B. And then sometimes they will give you, if you don't give you the angle, they will give you the value, which is about like triangle. Now, the reason why I want to mention this is because it's about triangles, and sometimes they mention it is an acute angle, it is an obtuse angle. If they mention that it is an acute angle, if it is an obtuse angle, they use sign here. For cos, if it's obtuse, cos B is in negative. So using the thing, you'll find out that cos B equals to minus 12 over 13. But for here, cos B equals to 4 over 5. It's not negative because A is in acute. And in acute angles, cos is positive. If you use the ASTC stuff, then after that you sub in the values in by expanding this, then you'll get the answer. And then how about this one? Cos 4A cos A plus sin 4A sin A equals to cos 2A cos A minus sin 2A sin A. How do I prove this? So at first thought you would think, okay, maybe I should let 4A equals to 3A plus A. But no, you don't want to do that. Instead what you want to do is you look at this thing. Doesn't this seem like cos 4A doesn't this seem like cos 4A minus A? Why will I yeah, cos 4A minus A, yep. So yeah, doesn't that seem like cos 4A minus A to you? Because if you look at the formula, cos A cos B minus cos A cos B plus sin A sin B is equal to cos A minus B. So okay, if it's see here, cos A cos B plus sin A sin B, wouldn't that equal to cos A minus B? So instead of converting, instead you wanna undo, right? You wanna undo this time. So if you undo, you get cos 4A minus A, which is cos 3A. And then cos 3A, then you convert back. 3A is equal to 2A plus A. So when you do 2A plus A, then you will get RHS. Another thing you can do is you can stop here. And then you will do write RHS is equal to cos 2A cos A minus sin 2A sin A, which is cos 2A plus A. Also equals to cos 3A. Then you can conclude that LHS equals to RHS. So there are two ways you want to try and solve the question. One is by doing only one side. The other one is by doing both and then concluding that they're both equal. But I prefer, but that one really depends on the question. Sometimes it's easier to do both. Sometimes it's easier to do one side. Okay, how about this one? How do I get sin square A minus sin square B? So first of all, you want to expand the identities and then multiply like normal. Then you will get A square minus B square. And then if you take and then this is an interesting thing that you did here. You see how they are both sine, and you see that this thing involves cos. So you want to try and get rid of the cos. So if you have sine and sine, you want to try and get and your answer here is cos. You want to try and convert that cos to sine. So so cos square B is equal to B is equal to 1 minus sine square B, and then multiply it, and then you will get sine square A minus sine square B. Okay, next. Prove each of the following trigonometric identities. Let me see why I mentioned this again. I think I mentioned this because of C. So if I look at C, you see how cot 2 is equal to 2 over tan 2A? And then you know that tan 2A is equal to, what was it again? Oh yeah, 2 tan A over 1 minus tan square A. How do I know that? Look at the identities again. So, no, not there. Here. So if you look there, then you sub it in, and then even though it's at the bottom, you can still use it. But remember to flip after that. So you bring it up like that, and then make the denominator the same. So there will be tan square alpha. And then you get the answer in the end, which is cot alpha. Okay, next I mentioned this one. So the reason why I mentioned this one is because you might think this is not related at all, but see, The keyword here is, the key thing here is, you see that this is sine 4x. So you can do something with sine square x. And then you can see that here is cos 2x and cos 4x. So you want to try and find a pattern which uses 2x. And then 2 times 2x. So you have to use something about about the cos 2 theta formula. And you know there are 3 forms. Cos square theta minus sine square theta, or 1 minus 2 sine square theta, or 2 cos square theta minus 1. So which one is it? Which one do I want to use? You see, it mentions you see that this thing here is actually sine square. So you want to use this one. So cos 2 theta is equal to 1 minus 2 sine square theta. Then you will get cos 2 theta minus 1 over 2 equals to no, not cos 2 theta minus 1. 1 minus cos 2 theta cos 2 theta over 2 is equal to sine square theta. So you got this. I'm sorry for the messy handwriting. I'm a bit tired right now. And then you put it in here. And then after that you multiply. And then you see how this is cos squared 2x. Then you remember that you remember this one instead. 2 cos square theta equals to minus 1. So 2 cos square x minus 1 equals to cos 2x. So therefore cos square x equals to cos 2x plus 1 over 2. But Anas, this is talking about 2x. This is talking about x. Why don't I just convert it back? The reason why you don't want to convert it back is because you want to find 4x. But how the heck do you find 4x? If you let theta equals to 2x for once, then you will get cos 2x minus 1 equals to cos 2 times 2x, which is 4x. Now you see the connection here. So now you see the connection here. Cos squared 2x is equal to cos 4x plus 1 over 2. You sub it in, and then you continue, and then you will get RHS. Next one. I believe this one is using okay. How do I want to turn this into this? Now, there are 2 things that you can do with this type of question. Normally, when you want to try and find a single angle, you want to try and remove the 1. There are multiple ways to remove the 1. Secondly, if you want to convert an angle into alpha over 2, then you must use if you want to convert an angle into alpha over 2, then you have to remember this one. Sine 2 theta equals to sine equals to 2 sine theta cos theta, right? But here is sine alpha, and here's alpha over 2, not 2 theta and theta. So what if you let alpha equals to alpha over 2? So therefore theta over 2. So therefore 2 alpha is equal to theta. So sine theta equals to 2 sine theta over 2 cos theta over 2. And then you can sub in here. Same thing with cos. The whole thing that I mentioned just now about this, you can convert that into theta over 2 as well. So you will get here the top. I'll just write the top part. So 1 minus, I want to convert it into what do I choose, sine or cos? So I want to try and remove the 1. So if I put 1 minus sine square theta alpha over 2, then 1 minus 1 is 0, right? Like that. Oh, no, sine square alpha over 2. It's 2 sine square alpha over 2. Let me just rewrite it again. 1 minus 2 sine square alpha over 2. And then let me see what else. And after that is what again? Plus 2 sine alpha over 2 cos alpha over 2. Cut out, so it becomes positive, and then you will get this top, and then similar for the bottom part. And then what do I do after this? I try and take out the common factor, which is sine. Now sine. For here it's cos. I cut out the same part, similar part, then you will get tan alpha over 2. For this one, we are using a T shape. I mean, a T formula. So T formula is where you let T equals to tan theta over 2. Then you will have a specific amount of formulas that you can use. Sine theta over 2, sine theta is equal to 2t over 1 plus t square. Cos theta is equal to 1 minus t square over 1 plus t square. And then tan theta is equal to this. Then you know that tan theta is equal to 24 over 7. So therefore 2t over 1 minus t squared is equal to 24 over 7. So multiply. Then you solve it like a normal trigonometric equation. And then not trigonometric equation, quadratic equation. So you'll get t equals to 3 over 4 or negative 4 over 3. So you'll get either tan theta over 2 equals to 3 over 4 or minus 4 over 3. Then you have to remember, theta is acute. Since theta is acute, theta over 2 has to be less than 45. Because if theta over 2 is equal to 50, then theta is equal to is 100. So it's more than 90. So you have to be careful about the angles here. If you know that theta is acute, then you must convert it into theta over 2 to make it less confusing. So divide the whole thing by 2, you get 45 here. Then you will have your general angle is and then you have to find the angle for each one. So I forgot the angle for 3 over 4, but I know this is acute. And then this is negative. Negative means it's in Q2 or Q4. What does that mean? This means it's not acute. So this is invalid. So the only answer you can use is 3 over 4. And then this question is similar, but I also want to remind that with the whole if cos 2 theta equals to 1 minus 2 sine square theta, you can also make it cos theta equals to 1 minus sine square theta over 2. Same thing here. You see how t is equal to tan theta instead? That's because we're dealing with 2 theta. Therefore, cos 2 theta is equal to 1 minus t square over 1 plus t square. It still works because it's still double of theta. So if here is because t is equal to if theta is over 2, and then here will be theta. But here we multiply it by 2. So if t is equal to theta, then here is 2 theta. If you get what I mean. So I'm just saying that you don't have to necessarily think that it's only for theta over 2. The main concept is if your tan theta is half the angle of the angle you're trying to find here, you can use T formula. The keyword here is half. So if here is theta, and then here is theta over 2. If here is theta, 2 theta, then here is theta. If here is 4 theta, then t is equal to tan 2 theta, and so on and so forth. It has to be half. It doesn't have to be theta over 2 exactly. Next one. Next one is about the next part. Let me see here. Here. Okay, I wasn't able to use much of this half angle formula yet, but but you have to be aware of when to use it, I guess, because there are some situations that you can use this. For example, let's say they give you sine square alpha over 2, and then they want you to find something in sine alpha. So they have not sine alpha, cos alpha. So if you convert this into plus minus 1 minus cos a over 2 square, then you will get equals to 1 minus cos alpha a over 2. So you'll be able to find cos alpha, cos a, I mean. So yeah, you have to identify what is the number on the left and what's the number on the right, and also remember, it doesn't necessarily have to be a over 2. As long as it's half the angle you're trying to find. Okay, half. Okay, now we're at here, which is the most confusing part. So sine A cos B equals to 1 over 2 sine A plus B plus sine A minus B. And then for sine A sine B, you have to put a negative sign at the front. Again, I'm not going to do the proving. I'm just going to walk through how to do the questions. So for here, what you might be wondering, why is it that I don't do why is it that I don't do this part? Why do I do these two first? Why don't do this? Because the keyword here is we're trying to make cos as small as possible. So if you're trying to make cos as small as possible, so you combine these two first, it's equal to 1 over 2 cos A plus B plus cos A minus B. A plus B, A plus B is 120, A minus B is minus 40, but since cos minus theta equals to cos theta, I will immediately write it as cos 40 as well. Then, how do I get negative 1 over 2? Because cos 120 is equal to minus cos 60, which is equal to minus 1 over 2. So I put it in. Where did this 1 over 2 go? It got multiplied into here, so that's why it is 1 over 2 cos 20. And after that, I multiply it in. Then you will see that it is 40 and 20. And some of you might go, okay, so I'll just so I'll just immediately take it out. The thing is, you can take it out. You can take it out. Let me try and do it myself. If I were to take it out, it'll be cos 20, 1 over 2 cos 20, and then minus 1 over 2 plus cos 40. And then remember that cos 40 is equal to cos 220. So cos 2 theta equal to 1 minus cos square 2 cos square theta minus 1. Right. So I will sub it in. So 1 over 2 cos 20 minus 1 over 2 plus 2 cos square 20 minus 1. So if I continue, you would see that I wouldn't be able to get the answer. If I continue multiplying it, I wouldn't be able to get the answer, because I will get here 2 cos cubed to 20 degrees. And there is a formula for this, but that's just too hard to do, right? That is too annoying to do. So instead, what I will do is, I will try and combine 40 and 20 first. The reason why I want to combine 40 and 20 first is, if I add that, I'll get 60, and cos 60 is an angle that you can find, which is 1 over 2. And then, so yeah, you don't have to immediately take the cos 20 out. You can continue it, and if you continue it, you can find cos 60, plus 40 plus 20 is 60, and cos 60 is an angle that you can find without calculator. Then you can turn it into 1 over 2, and then 40 minus 20 is 20. See, now you can find the 20 together. So 1 over 4 times this is 1 over 8 plus 1 over 4 cos 20. Then baru you can take it out, so you'll get 1 over 8 in the end. If you were to do the one that I did just now, you can, but the thing is, it will take a longer time to find the answer. Okay, next one is this one. So let's look here. Okay, cos 2 alpha cos alpha minus sin 4 alpha sin alpha. So cos 2 alpha cos alpha, you try and convert this into that half thing. So 2 alpha plus alpha is 3 alpha, and then 2 alpha minus alpha is alpha. And then sin 4 alpha sin alpha, this one, I forgot it where it is. Oh, here. Wait, let me just. Okay, 2 cos 2 alpha cos alpha. So cos A cos B, and then sin A sin B. So let me just go back there. Let me just go back to the page again. So sin 4 alpha sin alpha. So you will equal to minus 1 over 2 cos 5 cos 5 alpha minus cos 3 alpha. So you will get 1 over 2 cos 3 alpha plus cos alpha minus 1 over 2, this part. So minus is so the reason why it's 3 alpha first is because I put the negative in here. So this becomes plus, this becomes minus. So it's cos 3 alpha minus cos 5 alpha. So that is why here is negative. Because you know that if it's sine, then you must have a negative sign here because it's sine. So I was wondering why it wasn't plus, but I realized it's because the minus is instead put in here. So this thing is actually terbalik. So you can also write 1 over 2 cos 3 alpha plus cos alpha minus, right? So plus 1 over 2 cos 5 alpha minus cos 3 alpha. And then you get the same thing. So plus minus, so you will get this in the end. And then and remember, you can undo it. So how do you undo? So cos A plus cos B is equal to 2 cos A plus B over 2 cos A minus B over 2. So A plus B over 2 is 3. A minus B over 2 is 2. So yeah, you can undo. Where did the 2 go? It got cut by the 1.5. And then I don't know if I want to mention this part, but it is similar in a way. It is a similar format where you where instead of this multiply become plus, it's plus become multiply. So so it's sine A plus B over 2, sine A cos A minus B over 2, and then and here 2 sine 2A cos 3A. You leave it the same. So either you change this or you change this. So I would change or change this because it's easier. Or we'll change this part. So I change it into 2 sine 4 alpha cos 3 alpha. I take out the 2, then I take out the cos 3 alpha. So you will get sine 4 alpha minus sine 2 alpha, and then you use this into to become 2 cos A sine B, which is here, and then that's equal to your, and then after you go on, you should get your right hand side. Okay, I might be a bit confusing here, but the main thing that I hope you guys will understand will be this type of question, because this one took me a while to actually solve. The key to doing this is you leave the number in the middle on the side. So you do this and this first. The reason why is because if you add A and 3A together, you will get 2A. You will get sine 2A at the end. So that will make the whole question a lot easier to do. So in this case, you see, they moved this to the front. That's why it's taken down like that. And then 2 sine 2A cos A, 2 cos 2A cos A, and then minus sine 2A minus cos 2A. Common factor, take out the common factor. This is basically tan. and this basically cut out. And then same thing here. Move it to the side, move it to the side. Convert it into a multiplied form. So cos 5a plus a over 2, cos 5a minus a over 2, 2 cos 3a cos 2a, and 2 cos 3a cos 2a. So then you cut this part out because these are the common factors. And then you see cos 2a minus 1, cos 2a plus 1. And then remember. We want to take out the 1. How do you do that? Cos 2a is equal to 1 minus 2 sine square a. Also equals to 2 cos square a minus 1. So we sub it in. We try to use the 1 that removes the 1. So here is plus 1, here is minus 1. So you use this one. So you will get minus 2 sine square a. Bottom is plus, so you use 2 cos square a. And then it will be minus 10 square a, which is your right hand side if you look here. The last thing that I want to mention will be about the triangles, because triangles, the main thing you have to know is a plus b plus c in the angles of a triangle is always going to equal to 180 degrees. Then you can play around. So a plus b over 2 is equal to 90 minus c over 2, because divide, this one becomes 90, right? So if you were to put sine at the side, because they're basically the same value, so you can put sine at the side. If you were to put sine at the side, this 90 minus a thing kan, sine 90 minus a is equal to cos a, right? So if it's 90 minus c over 2, so it's equal to cos c over 2. So sine a plus b over 2 is equal to cos c over 2, and vice versa. And then another thing that you want to remember is if you get cos a plus b, right? A plus b is equal to 180 minus c. So it's equal to cos 180 degrees minus c. This, remember, cos 180 minus theta is equal to minus cos theta, right? So it will be equal to minus cos c. So you want to try and use as many of these as possible to sub it into your question. So I took a picture of A. So sine A plus sine B plus sine C. I will put sine A and B together first. You use the you turn the addition into the multiplication. So 2 sine A plus B over 2 cos A minus B over 2. You cannot do anything with this yet, but you know that A plus B over 2, sine A plus B over 2 is equal to cos C. Right? Cos C over 2, I mean. So that's where this thing comes from. But you can directly turn it there. If you know, don't directly turn it yet. Try and make them the same first. So try and make them the same first. Oh, my tip hurts. Okay. Sine C. Remember that C is equal to 180 minus A plus B, right? So I put that in. Then you will get sine 180 minus A plus B. But remember, 180 minus theta is equal to, sine 180 minus theta is equal to sine theta. So this is sine A plus B. I put it in. Then remember, sine theta equals to sine 2 sine theta over 2 cos theta over 2. Why do I want to use this? Because I want to try and get them all to become A over 2, B over 2, C over 2. You see that they're all divided by 2, right? So I want to try and get as many half as possible using all the methods that I can use. So 2 sine, take out the 2 sine A plus B over 2 out. And then remember, it's equal to cos C over 2. And then here, cos A minus B over 2 plus cos A plus B over 2. You can turn this plus thing into multiply, which is what they did here. And then remember that this minus B over 2 thing, right? The minus doesn't matter because it's cos. So cos minus B over 2 is equal to cos B over 2. So that'll be 2 cos A cos B over 2. 2 times 2 is 4. So it's 4 cos A over 2, cos B over 2, cos C over 2. And that's your answer. Okay, the last one that we'll mention about is general solution. You have to know the general solution for each, which is this is for sine, this is for cos, this is for tan. But you also have to remember that sine and cos have some special cases. For example, if sine x equals to 0, x equal to n pi, if equal to 1, pi over 2, minus 1, minus pi over 2. And then if cos x equals to 0, then x equals to n pi plus pi over 2. If cos x equals to 1, x equals to 2n pi. If cos x equals to minus 1, then x equals to 2n pi plus pi. But there is a reason why you can do that. There's a proof to it, but we're not going to care about the proof. We want to care about general solution. So if you're finding general solutions, right, and you find like 0, 1, or minus 1, you do not use this to find the answer. You do not use this, you do not use this. Instead, you try and find its own special case. Okay, so I'll get to this last because this is a special thing. But for the normal one, sine 3x plus 2 equals to 1 over 2. So my teacher would like to try and let alpha equals to let sine alpha equals to 1 over 2. So alpha equals to sine minus 1 over 2, which is equal to 30 degrees. So alpha, remember, in this thing, I did not mention much about it. But the thing here is alpha must be a basic angle. And the basic angle actually depends on what it is. For sine, it's between negative 90 and 90. For cos, it's between 0 and 180. For tan, it's between negative 90 and 90. I would love to say why, but that's not my main priority. You just have to remember that for sine and tan, you can put it as negative. For cos, you can put it as 0 or 180. But to be fair, right, you can easily find the answer by using your calculator. They will immediately put it in this category. So yeah. Okay, back to this. So your basic angle alpha is 30 degrees. But since they want to use radian, pi over 6. So x is your angle. Remember, x equals to n pi, I think it was plus minus 1 n alpha. So x here is 3x over 2. X plus 2 equals to n pi plus minus 1 power n pi over 6. Then remember, your general solution must be in x. X equals to what? So you have to use like your normal algebra stuff and move all to the other side, and then you will get x. So yeah, just one thing to keep in mind. If you have an angle here, then this whole thing equals your general solution. But you want to find your general solution in the form of x. So you have to move everything to the other side and find x. And then I think we're almost done. For this one, this is about general solution. But sometimes it involves domain. So if you're trying to solve equations, you want to try and find sine x equals to what? Cos x equals to what? Tan x equals to what? Or maybe like this one, factorize. Factorize, then you will get two answers. So yeah, you want to try and get it so you can find sine equals to what, cos equals to what, tan equals to what. So in this case, 2x sine x minus 1 equals to 0. This is easy. Sine x equals to 1 over 2. You know that the basic angle of x is 30. So and then you know that it is positive in Q1 and Q2. So 30 and 150. So that's your answer here. And then for here, and then for here, 4 sine square x equals to 3. No, not this one, not this one. This one, 2 cos square x minus 3 cos x minus 2 equals to 0. So you can do this the same way as you do quadratic equations. So it's like 2x squared minus 3x minus 2 equals to 0. That will equal to 2x plus 1, x minus 2. So let x equals to cos x. It does the same thing. So you will get cos x equals to negative 1 over 2 or cos x equals to 2. But remember, cos and sine have to be less than 1. So since it's more than 1, this is invalid. There's no solution for that. So instead you focus on this. You get cos x equals to minus 1 over 2. So minus negative is in quadrant 2 and quadrant 3. So it is equal to 180 minus 60 and 180 plus 60. Is this. But be careful of this quadrant thing. You need to make sure that you get all of the available angles in the quadrant. So sometimes it will be negative 180 x 180. So so in this case, if this is the case, and then I get x equals to 120 240. However, 240 is not in there. So you assume nah, so it's only 120, right? No. 240 is equal to negative 120. And negative 120 is in this domain here. So you need to be careful when playing around with the numbers. Remember that theta is equal to negative 360 minus theta. So the key to solving this question is to make sure that you get all of the numbers that could be in the domain. And then I think this is the last one. Find x in the range minus pi to pi over 2. In long story short, this is negative 180. This is 90. So you do that, you get 10x plus pi over 2 equals to negative 1. And then after you do that, you know that you know that x has to be in this range, right? In this range. But this is x plus pi over 2, pi over 12. So you need to add pi over 12 to all of them. So minus pi plus pi over 12, x plus pi over 12, pi over 2 plus pi over 12. And then with some simple math, you will get minus 11 pi over 12 is less than or equal to x, less than or equal to 7 pi over 12. Okay, not x plus pi over 12. So yeah, if the angle here is not just x but x plus a certain angle, you must add that angle into your range. So when you add it into the range, you must add it for here, here, and here, like I did here. Plus 12, plus pi over 12, plus pi over 12, plus pi over 12. So now you have a new range. And now you want to try and find all of the angles that could be in this range. So since 10x equals to minus 1, that means x is in Q2 or 4, which is equal to, and then this is 45 degrees. So there are two ways to find it. You either use this directly, and then you use general solution. So x equals to n pi minus pi over 4. So and then after that, if you let n equals to 1, n equals to minus 1, then you can find the answers. But I wouldn't want to do that because that is confusing for me. So instead, I want to remember what is the basic angle, which is 45 degrees. So if 10 minus 1 is equal to 45 degrees, therefore 10 minus 1 is equal to 180 minus 45 and 360 minus 45. So you will get 135 and also 315. But then remember, this is in radian. So so you have to convert it into radian form. So 135 times pi over 180. This is 3, this is 4, so it is 3 pi over 4. And then 315 is 7 pi over 4. But wait, Actually, wait. Yeah, 315 degrees is equal to 7 pi over 4. But remember, 7 pi over 4 is greater than the domain here. Because it's equal to 21 pi over 12. And anyone can tell me 21 is bigger than 7. So you would assume that you can just take it out. But the true case is 21 pi over 12 is equal to 2 pi minus not 25 pi over 12, 7 pi over 4. So it's equal to minus 2 pi minus 7 pi over 4. Because remember, theta is equal to minus 360 minus theta. So you do that, you will get pi over 4 here instead. Negative pi over 4. So that's how you get your answer. So so you get x plus pi over 12 equals to negative pi over 4. Or the other one is what again? The other answer is 3 pi over 4. But that is also 9 pi over 12. More than 7 over 12. 7 pi over 12. So you cannot use this. And then if you do 2 pi minus 9 pi over 12, or 360 degrees minus 315, then you get minus 45. And not 360 minus 315. 360 minus 135. So you will get, so x plus pi over 12 is equal to either minus pi over 4 or so the two answers are 3 pi over 4 and 7 pi over 4. This can be turned into minus pi over 4, but this can only be turned into minus 5 pi over 4. And if you multiply by 3, you will get minus 15 pi over 4. This thing is minus 11 pi over 12. No, minus 15 pi over 12. 15 is less than 11. Negative 15 is less than negative 11. So both this and this don't fit the criteria. So you only have one answer, which is x equals to negative pi over 4. But remember, again, your answer here is x plus pi over 12. So x plus pi over 12 equals to x minus pi over 4. So you have to put it to the other side, minus, get the answer. Okay, so yeah, I think that's all for the important part. But I want to mention some extra questions that might be counted as trick questions. So, number 1, sin x over 1 minus cos x equals to 0. That if a fraction equals to 0, it means two things. X equals to 0 and y cannot be 0. Because if y equals to 0, then you will get 0 over 0, which is infinity, right? And if you get 0 over whatever number it is, it will still equal to 0. So that's why x equals to 0. So sin x equals to 0, therefore use the special solution, x equals to n pi. And then you know that 1 minus cos x cannot be 0, so cos x cannot be 1, and so x cannot be 2 n pi, another special solution. So if x is n pi and x cannot be 2 n pi. Now remember, we're talking about general solution. So this n can be whatever you want. It can be k, it can be 2k. But this implies that your angle will always be even. Right. So n can be odd or even, but 2n is always even. So because 2n is always even, that means x cannot have n being even. So n must only be odd. Since n can only be odd, the general term for odd is 2n plus 1. So that's why you have 2n plus 1 pi here. And then lastly, most people would would be like sine x equals to 45, for example. But how about sine x is equal to sine sine x equals to 45. Sine x is equal to square root 2 over 2. How about sine x is equal to sine 45? Do I need to convert this into if I convert this into a general term, which is square root 2 over 2, I can use this as my basic. I can use 45 as my basic angle, right? Because x will therefore be equal to 45 degrees. I mean alpha. The basic angle will be 45 degrees. So instead of doing all of those annoying stuff, I can leave it as 45 degrees. Then I can do x equals to n pi plus minus 1 power n 45. Oh wait, remember, since I'm talking about 45 degrees, I need to make sure that it is 180 degree n. Because it's either going to be both degree or both radian. Okay, both degree or both radian. Both are acceptable. Oh wait, I forgot one more thing. That I forgot to mention the whole part. N must be an element of z. So remember to write n is an element of z. So yeah, since I can immediately make this my basic angle, I don't have to do the whole thing of trying to turn it into a value and then try to find the basic angle and then do it. This is your basic angle. So same thing here. Pi over 2 is going to be 90 degrees. So 90 degrees minus theta, this is an angle that is basic. It is going to be a basic angle. The reason why is because if cos theta is equal to sine 90 minus theta, we are assuming that theta here, theta is basic. So yeah, we only do this if it is in quadrant 1, right? If it's in quadrant 1, then then the angle is definitely basic. So if you see like 90 minus x on 90 minus x on 90 plus 2x, then no, this one cannot. 90 minus 2x. If it's 90 minus something, so in this case, sine 2x is equal to cos 3x, which is sine 90 minus 3x. This is your basic angle. So you can immediately let alpha equals to 90 minus 3x. Then what you can do here is you can sub it in immediately. So if I sub it in immediately, alpha is equal to pi over 2 minus 3x. X is equal to 2x. So 2x equals to n pi minus, plus negative 1 power n pi over 2 minus 3x. Then remember, you must let x equals to whatever it is. The term here is x cannot appear on this side. X must be alone. So you take it out. You take it out. Factorize the x out. So it becomes like this, and then divide, and then this is your answer for x. So I don't know if it will appear in exams, but it's just a heads up. If you get something like this, you let cos alpha equals to cos 90 minus alpha. Since cos beta equals to cos 90 minus beta. Since alpha is basic, and this is basic, therefore alpha equals to 90 minus beta.